Hello guys, this is Rahul. I will explain about the application of automata in game theory. Automata theory is an existing theoretical branch of computer science. It established its roots during the 20th century, and mathematicians began developing both theoretically and practically machines which limited certain features of man, completing calculations more quickly and reliably. The word automata itself closely related to the word automation denotes automatic process carrying out the production of specific process. Simply stated, automata theory deals with the logic of computations with respect to simple machines, referred to as automata. Through automata, computer scientists are able to understand how machines compute functions and resolve problems, and more importantly, which it means for the function to be defined as compatible or for a process to be described as decidable. Automations are abstract models of machines that perform computations on an input by moving through a series of states of configuration. At each state of the computation, a transition function determines the next configuration on the basis of finite portion of the present configuration. As a result, when the computation reaches an accepting configuration, it accepts that input. The most general and powerful automata is the Turing machine. The major objective of automata theory is to develop methods by which computer scientists can describe and analyze the dynamic behavior of discrete systems in which signals are sampled periodically. The behavior of this discrete system is determined by the way that the system is constructed from the storage and combinational elements. Characteristics of such machines includes inputs, assumed to be sequence of symbols selected from a finite set one of input signals, namely set one is a set x1, x2, x3, and so on xn, where n is the number of inputs and outputs. Sequence of symbols selected from the finite set Z, namely set Z is a set of z1, y1, y2, y3, and so on ym, where m is the number of output states. Finite set q, whose definition depends on the type of automation. There are four major families of automation: finite state machine, push-down automata, linear bounded automata, Turing machine. The finite state machine is the simplest automata, and the Turing machine is the most complex. The focus of this project is on the finite state machine and the Turing machine. A Turing machine is a finite state machine, that the inverse is not true. Automata used in the game theory. Finite automata is the simplest machine to recognize patterns. The finite automata or state machine is an abstract machine that has five elements or tuples. It has a set of states and rules for moving from one state to another, but it depends upon the applied input symbols. Basically, it is an abstract model of a digital computer. The following figure shows some essential features of general automation. In this figure, there are input, output, state of automata, state relation, and output relation. Now I will tell the input and output in this figure. In this figure, the starting state is A, and the ending state is B. This is an example of finite automata that checks whether the string is starting and ending with 1. Adaptive automata. An adaptive automata is a complex, ide- idealized machine used to recognize patterns within inputs taken from some character sets C. The job of an adaptive automata is to accept or reject an input depending on whether the pattern defined by the adaptive automata occurs in the input. Now I'll discuss about cellular automata. A cellular automata is a collection of cells arranged in a grid of specified shapes such that each cell changes states as a function of time according to a defined set of rules driven by the states of neighboring cells. Now, a differentiate between the game theory versus automata. In game theory, presenting players with the strategies directly affects the performance of the players. Utilizing the power of automata is one way for presenting players with strategies. It was found that finite automata, adaptive automata, and cellular automata are widely adopted in game theory. The applications of finite automata are found to be limited to present simple strategies. In contrast, adaptive automata and cellular automata are intensively applied in complex environments, where the number of interactive players like humans, computer applications, and etc. is high, and therefore complex strategies are needed. What was the piece has game? Any problem with interacted participants and actions can be treated as a game. When car drives put a plan to drive in heavy traffic, they're actually playing in driving game. When users bid on bidding based websites, they're actually playing an act- actioning games. In election, choosing the platform is a political game. The owner of a factory deciding the price of this product is an economic game. Actually, game theory can be presented in wide range of applications. Game theory. What is game theory? Game theory is a mathematical tool that can analyze the interaction between individuals strategically. The interaction between agents who may be individual groups, primes, and in- interdependent. These interdependent interactions are controlled by the available strategies and their corresponding. And next slide about automata in game theory. The application of automata in game theory pay off to participants. However, game theory studies the rational behavior in situations involving indeterminately. Therefore, game theory will only work when people play games rationally and it will not work on games with cooperational behavior. Generally, the game consists of the following entities. The entities are like players, where one side of the game tries to maximize the gain, while the other side tries to minimize the opponent's score. However, these players can be humans, computer applications, or any other entities. Environment. This includes board position and the possible moves for the player. Successor function. The successor function includes actions and returns a list of states like move must state. It is a pair, where each pair indicates a legal move and the resulting state. Terminal test. Terminal test specifies when the game is over and the terminal state is reached. Utility function. The utility function is a numeric value for the terminal state. Applications of automata in game theory. Automata theory has presented various types of automata with different characteristics. We will go through the applications which have successfully utilized the concept of automata in game theory. Now I will discuss about applications of finite automata. Back to 1985, Nyman tries to model the fact that players can do only bounded computation. By modeling the iterated prisoners, the dilemma players as finite automata. 1 year later, Rubinstein tries to show that costly computation may affect an agent's utility. Rubinstein assumed that players use a finite automation to play the game instead of using the tragedy directly. It was clearly stated that a player's utility depends upon the automation moves and the complexity of the automation structure. In other words, automata that use more states are capable to represent more complicated procedures. In 2000, Doris, the first who formalized the idea of finite automata in Prisoner's Dilemma instead of modeling players as fi- polynomially bounded Turing machine. Recently, finite automata has been widely used to represent player tragedies in game theory. For instance, the researchers of the work mentioned in has considered server experiments and the results showed that finite automata has significantly improved the performance of n-player prisoner's dilemma. However, finite automata are found efficient in representing simple strategies in game theory. Nevertheless, game theory is interested in representing simple strategies since many real-life applications do not require complex strategies to achieve their goals. Mathematically, finite automata are four couple structures described by R as follows: S, I, F, S stands for set of states, I stands for input symbol, F is the transition function, SO is the initial state. Finite automata are widely used in game theory. For instance, in the iterated n-player precedence dilemma, finite automata can be used to represent player strategies. The automata states represent the player's action and the input is the strategy profile observed from the other players. Example, the number of cooperated agents. Therefore, if n represents the number of players in the game, then the set uh, 1 is defined as I is equal 0, 1, and so on n minus. The set of states S can be divided into two states C, D, such that the players cooperate or defect if it belongs C or it belongs D respectively. The automation represents in figure as four states C1, C2, and D1, D2. The arcs between the states represent the transition. The four states can only be triggered by the numbers associated with the arcs, resulting in the transition between the states. In this example, f of c1, 0 equals to d1 and f of d2, 2 equals to c2, and so on. The initial state is the one with an empty arrow in its direction, so equals to c1. Example on representing iterated and player presence dilemma tragedy. This is an example of representing iterated and player presence dilemma. The following sequence of plays illustrate the role which finite automata can play in representing strategies. First, the player selects C1 as its initial state. If in this round none of the other two players see, the total number of cooperative will be 0. The transition 0 will change the current state from C1 to D1. In the following round, the agent will play D, since the current state is B1. Assume that one player is cooperated, therefore the total number of cooperated will be 1. The transition 1 changes the state from D1 to D1 itself. In the next round, the player will play D again. Limitations. However, using finite automata as a modeling language has its limitations. Finite automata are only capable to recognize regular languages. In other words, it is possible to guarantee arrival at a specific state only for a determined classes of input sequence. Conclusion. Presenting players' strategies in game theory is one of the factors which affects the player's performance significantly. In this work, I have analyzed the characteristics and the underlying structure of excited types of automata. Consequently, we have explored the applications of automata in game theory. Thank you.